Hello everyone, my name is Sanju and I'm a PhD student at the UNC Chapel Hill. Today, I would like to present my research about the value of transitioning from diesel backup generators to solar PV plus storage microgrids using empirical data and an energy optimization and integration model. The US grid infrastructure has been challenged by extreme weather events. For example, California has suffered from power outages due to frequent wildfires, including the planned outages called public safety power shutoffs, which is wildfire risk mitigation. And concerns about grid reliability have raised demand for backup power, including diesel generators. However, diesel generators emit greenhouse gases and various air pollutants, and diesel fuel itself poses some limitations and risks. So I wanted to compare the resilience value of diesel backup generators and renewable energy-based backup generation, especially for public buildings which serve as critical facilities during an emergency. I designed a 20-year analysis for the California Department of Transportation, which is Caltrans. I developed 6 scenarios in total based on what type of energy technology would be chosen between diesel backup generators and PV plus storage microgrids and the duration of an outage. I set up 3 different outage durations here: 12, 24, and 41 hours. 41 hours is the annual average duration of the PSPS event in California. This research found that diesel generators show significantly higher emissions regardless of the outage duration, because the site should burn diesel fuel during an outage, but also purchase more grid electricity when no outages. Cumulative cost, including capital cost, O&M cost, fuel cost, grid electricity cost, and emissions cost, also indicate that PV plus storage microgrid would be a more economic choice than diesel generators over a 20-year period. For a short term, diesel generators may be an economic choice due to the lower capital cost, but its grid purchase and emissions costs make them more expensive for a long term. The result demonstrates that the transition would save about $3 million of public expenditures over a 20-year period. There are more than 10,000 diesel backup generators in public buildings and critical facilities in the 22 air districts of California, and the same application would save about $31 to $386 million annually. I also developed a marginal resilience curve based on the optimal capacity of PV, battery, and diesel generators for different outage durations. The curve indicates that installing more PV or diesel generator capacity does not necessarily add more resilience past a certain outage duration. Rather, it would get more important to secure more energy storage as the outage duration increases. Few studies have defined the strategies for different durations of an outage, but the marginal resilience curve calls for different strategies for various outage durations, especially extended ones. This study implies significant advantages to weighing cross-disciplinary co-benefits during decision-making, as the result shows higher values of PV plus storage microgrids despite they bear higher upfront costs. This concludes my presentation. Thank you.